So number 10, difference quotient and limit of a difference quotient. Quotient means fraction, a ratio of two things, and difference meaning we have a difference here. Something minus something, something minus something. That's difference, and quotient is the fraction of those. Okay, and then we have limit of a difference quotient. So let's see what that is. So if we have the graph of a function, and if I have a graph of a function, let's say this is the graph, and I am fixing my point x there. So this point is f of x. Now I'm going to look at, here it says h. H is approaching 0. So it didn't say h approaching 0 plus, right? It says h approaching 0. So h can approach 0 from the right of 0 or from the left of 0. So h itself can be positive or it can be negative, but h is never equals to 0 because it says h approaches to 0. So coming back to here, if h is positive, let's say this is h, then this point will be x plus h. So I have corresponding point, which will be, if I extend it, if I extend the y, right, y-axis, then this point will be f of x plus h. And if I join these 2 points as a line, then what was the name of this line? It was secant line. And if we look at change in y over change in x, this is the slope of the secant line. That becomes the slope of the secant line. That's the slope of the secant line, right? So h can be over there, and if h is less than 0, then if that is h, so h is less than 0, then we get x minus h. X plus h still. H is less than 0. So, for example, if h is minus 0.5 is here, that is when h is 0.5, for example, right? So that is x plus 0.5, and here it is x minus 0.5. So it is x plus minus 0.5. So it is still x plus h. Yeah. So I have the point there, and I have a corresponding point here. And since h itself is less than 0, this is again f of x plus h. And I can join this point and this point. And I have another secant line. So that is slope of the secant line. So that expression tells us the slope of the secant line in either case. And I can further cancel x here and write that as f of x plus h minus f of x over h. And if I keep going, if I take h smaller and smaller, So h approaching 0. So my point x plus h approaches x. Then I'll get a line tangent to the graph. See, my original graph was red, yeah? Then I'll get a line tangent to the graph. So if I look at limit h approaches to 0 of this difference quotient, then I get the slope of the tangent line. Okay, so that's the idea. So let's fill in the blanks. So difference quotient is slope of a secant line, right? Secant line. And limit of a difference quotient is slope of a tangent line. And then that was the slope of the tangent line. Yeah, so you will have to memorize this definition. Is h equals to 0 ever? No. What does this mean? It means the slope of the tangent line at the point x comma fx to the curve is L. It means if I have such graph, right? Let's say this is x, then I have the point x comma f of x to the graph, and I have a tangent line, and the slope of this tangent line equals to L. That's what it means. Now suppose I want to find the equation. What's the equation of this tangent line? Equation of this tangent line, right? Equation. Well, how do you determine the equation of a line? You have to know one point where it goes through x0, y0, and then you have to know the slope of the line. Then what is the equation of the line? That's y minus y0 equal to m times x minus x0. Right? So, using that formula, we know the slope. Slope is L, and this is the point where the line goes through. So the equation of the tangent line, equation of the tangent line is, if we call this point as a comma b, then the equation of the tangent line is y minus b equal to L times x minus a. Okay, so equation of the tangent line to be memorized. Now let's look at limit at infinity. So far we have seen limit x approaches to c f of x, where the c was a finite number. But what does it mean by limit as x approaches to infinity? We say that f of x has the limit L as x approaches to infinity, and write this, that L is definite number, finite number, definite number. When do we say this? If this happens. So if I look at the picture, suppose I have such graph, okay, and this approaches to L. It never touches the line L, but it gets close to it, for example. Okay. So take any epsilon band. So that is epsilon, top and bottom. Then I can find corresponding m on the inputs. So whenever my x value is bigger than m, the graph is inside of this band. This is also true even when I narrow down this band. If I look at smaller epsilon, narrower band, then I can go further and call this number m, and whenever my inputs are bigger than m, my outputs also goes into this narrower band. Yeah. If I can do that for every epsilon, no matter how small my epsilon is, if I can find m such that whenever my inputs are bigger than m, then my outputs is inside this epsilon band. If that happens, then we say limit f of x as x approaches to infinity is L. Okay, so let's fill in the blanks. If for every epsilon positive there exists m, some positive number m, such that whenever x is bigger than m, the difference between f of x and L is less than epsilon. So that's formal definition of this expression. Okay, you don't have to memorize this. Don't memorize it. I'm just giving you precise definition of what it means, but you don't have to memorize. Now, when do we say f of x limit as x approaches to minus infinity? Minus infinity of f of x is L. Again, that L is a definite number. So it is exactly the opposite situation. So now the graph goes like this. As x approaches to minus infinity. So let's say this is L, and I look at epsilon band, then I can find n such that whenever my inputs are less than n, my output is inside this band. I can do that for every epsilon small. If I narrow down this band, then I can go out further in the inputs, and whenever my inputs are smaller than n, my outputs are inside this band. In such case, we say limit x approaches to minus infinity of f of x is L. So let's fill in the blanks. If for every epsilon positive there exists n less than 0, such that whenever x is less than n, my output and L is within epsilon band. So that's what it means. Okay. Again, you don't have to memorize. Don't memorize. But that's the exact definition. So 3, same limit laws hold if the limit is finite. So the limit laws, we we used limit law when for limit x approaches to c, f of x equal to L, limit x approaches to c, g of x equals to m, where L and m were definite finite numbers, and then c was also a finite number. But we can use limit law for infinity or minus infinity if these are still definite finite numbers. Okay, so for example, I have limit of the sum, right? Now it can be written as even with infinity, we can apply limit law. Limit x approaches to infinity of 5 plus limit x approaches to infinity of 1 over x. That is because limit of the constant function 5 as x approaches to infinity, the limit is 5. It's a finite definite number. And as x approaches to infinity, 1 over x goes to 0. That is also a finite number. So we can apply limit law. So limit of the whole quantity 5 plus 1 over x can be broken into sum of the limits using the limit law because each has finite limit, and its value is 5 plus 0, which is 5. B. So that's limit of the sum is sum of the limits. B. If we have this, well, I can write that as limit x approaches to minus infinity of pi times square root of 3. This is constant multiple of a function. So that is alpha f, right? Constant limit of constant multiple of the function. Limit of constant multiple of the function is constant multiple of the limit of the function because here limit x approaches to minus infinity of 1 over x squared. It has finite limit 0. So we can apply limit law because this has finite limit, right? So by limit law, it is pi square root of 3. When you take the exam, you have to state this. Okay? Constant times limit of the function 1 over x squared. So we get constant multiple of the limit of the function, and we get 0. C. Limit of what kind of function is this? This is polynomial over polynomial. What was the name of such? Yeah, it's a rational function. Rational function. So we have a quotient. Limit of quotient is quotient of the limits. That was the limit law. So this is equal to limit x approaches to infinity 5x squared plus 8x minus 3 over limit x approaches to infinity 3x squared plus 2 by limit law, right? Now if you do this on the exam, that's very wrong. Okay, that's wrong. Why is that wrong? We cannot apply limit law like this. Why not? Right? That's very important, right? Why not? Because the limit of each is infinity. infinity is not a definite number, so you cannot use limit of quotient is quotient of the limits in this case. This is very wrong, right? Wrong, wrong, wrong. Okay, so how do we do such a thing? You have to make sure that each limit is finite, okay, to use limit law. So to do that, my function is 5x squared plus 8x minus 3. 3x squared plus 2. To do that, I'm going to divide top and bottom by highest power in the expression. Highest power. That's x squared and that's x squared. So we are dividing by x squared. So this is actually 1, right? That whole fraction is 1. So by multiplying 1, I am not changing my original function. But by doing this, by this division, I can change the limit into finite numbers. So it was this. Since x is approaching infinity, I know that x is not 0 because x is a big number. So I can divide by x squared safely. So when we do that, so limit carries on. I am not doing the limit yet. I'm just rewriting my function. Okay. So I have to distribute 1 over x to each. This to each. Then what do we get? We get 5 plus 8 over x minus 3 over x squared over 3 plus 2 over x squared. That's what we get. Now, what did we achieve by doing this? If we look at the top, that goes to 5 as x approaches to infinity. And the bottom approaches to 3. These are finite numbers. So we can use limit law. So once we do dividing by highest power, then I am able to use limit law. And we can do limit of the quotient is quotient of the limits. So this limit of the top, 3 over x squared over limit of the denominator by limit law, 3 plus 2 over x squared. So we get 5 over 3. Okay. So don't forget to divide by highest power to make that into finite limits so that you can use the limit law. Next. So as it is, the numerator approaches to minus infinity, denominator approaches to minus infinity, so you cannot use limit law as it is, right? So divide by highest power. What's the highest power? Yes, x cubed is the highest power. So divide top and bottom by that. So 1 over x cubed over 1 over x cubed. And then distribute. Then this is limit x approaching minus infinity, and we get 11 over x squared plus 2 over x cubed over 2 plus 1 over x cubed. Now we can apply limit law because top and bottom has finite limits. So by limit law, limit of the quotient is quotient of the limits all over limit x approaches to minus infinity 2 plus 1 over x cubed. So then this is 0. Now each has finite limit. So limit of the sum is sum of the limits. 0 plus 0 over. So here again we are doing limit law, right? Same thing here. 2 plus 0. So we get 0 as the answer. So make sure you write, you justify each step when you do when you solve in the exam or quiz. E, I have cube root of x minus fifth root of x, etc. Okay, so this is again that approaches to minus infinity, that approaches to minus infinity. So we cannot do limit law as it is. We have to divide by highest power. So if I rewrite this function, that is x to the 1/3 minus x to the 1/5 over x to the 1/3 plus x to the 1/5. Now, out of 1/3 and 1/5, which is highest power? Yes, 1/3 is higher than 1/5, right? So we multiply top and bottom by 1 over x to the 1/3. 1 over x to the 1/3. Then this and that disappear, and then we will have to multiply this over here as well, right? So the expression becomes the following: is limit x approaches to minus infinity, we will get 1 minus x to the 1/5 minus 1/3, because we're dividing by 1/3. That will become this, yeah. Over we get 1 plus x to the 1/5 minus 1/3. So far so good. And what is x to the 1/5 minus 1/3? It is x to the 15, 3 minus 5. So x to the minus 2 over 15, which is 1 over 15th root of x squared. So if we replace these two by that, then as x approaches to minus infinity, this will go to 0, that will go to 0, that will go to 0. So we have finite limits. So by limit law, it is 1 over 1. So So the limit is 1.